Good morning. So today what I want to do is we're going to introduce you to a couple of quick features dealing with the diesel engine. So a lot of you guys are into your reading, you've read some stuff, and just to help speed you up or to help explain how the reading or what your reading is, I'm going to just kind of briefly go through some of the features you're reading about, give you a better visual on what it is. So I'm going to start down at this end of the table and work my way down that direction. And so a couple of the features I want to look at. So we're just going to look at this block real quick. This block here has something that's rather unique to diesel engines, and that is a tunnel crank. And so here is the crank that belongs in this engine. You look at it, you'll notice it has a big, large center main bearing. And when you look at it, this main bearing looks like this circle that you see here. There's another circle like this that's missing that should go here. And a tunnel crank is called that because it actually goes in. So you stick the crank in from the end and actually goes down inside. And that's why this circle's here. Once you put it in, there's a bolt that comes up from the bottom. That bolt will go into this hole that's here, and that's what keeps this this housing from spinning once you put it in there. So this is a tunnel crank versus this block here, which has a crank that would bolt in from the bottom. So you take your main bearing caps off, you put your crank in from the bottom, and then you put your caps back on. And this style is very common in most larger engines. Most engines, crank comes in from the bottom. So
This one built really tough.
So the tunnel crank, Kubota uses a tunnel crank. This particular engine here, I believe, is an Onan, and they're using a tunnel crank. There's a Hotz I've seen has a tunnel crank. When you get into a real small, compact diesel engine, it's not that uncommon to see a tunnel crank. And so you just put it in from the end, and then your connecting rods and everything still come up from the bottom. So you still have an open access to the bottom. This particular one here, I can't access it from there, but there. So I would reach in through the side here and I would tighten up the connecting rods once I put them together. So it's just a different style, different kind. So there are different kinds. They're still accomplishing the same job, still doing it. I still have replaceable bearings on all of the main bearings on here. They are all replaceable. So I'd still perform the same tasks. I just install it a little bit different. So I just wanted to point that out because you kind of will be reading about that in your reading. The second major difference between these two engines, we'll just roll this out of the way. The next major difference between these two engines is the type of fuel injection system. And I'm trying to do is kind of lead us up to the components that are on this table here. This particular engine here has a direct injection system. This one over here is indirect injection. The head that's on this one, if I were to install my head, the injector will go in. There's a pre-combustion chamber that you'll be reading about in your textbook. The pre-combustion chamber is the cavity that's underneath this little plate. If you took this cap off, and this little cap would be like, could look like this, it could look like this. There are lots of different styles out there, lots of different designs. This is by pre-combustion caps, and they actually insert it in there. So the injection system shoots into this pre-combustion chamber. That's where the ignition begins, and then the flame will flow out and flows across the top of the piston. This particular one here is direct injection. A direct injection, you see the little hole. This little hole is where the tip of the injector comes out. This is the injector versus this one. So the injector for this one looks like this. And the injector for this one looks like that. The major difference is if you were to hook this up to an injector tester and put pressure on it, the fuel stream on this one will shoot in a conical shape straight out. So when I stick it into this hole, so looking at it, I'm going to stick it into the hole. It's shooting down directly into that little pre-combustion chamber. It's aimed towards the little exit hole here. So the flame begins in there and the flame shoots and the fuel sprays through and it burns across the top. So the conical is trying to shoot for that hole and go down through that cavity and come out. So that's the direct or indirect injection. Direct injection would mean that the tip of the injector will actually come through the hole. And so you see here, there's the tip of my injector. It's directly on top of the piston. Because it's directly on top of the piston, this thing has to be oriented perfectly. So the clamp that holds it in place holds it in a certain direction. On the little tip here, if you take magnifying glass or have really good eyes, you'll see that there may be 4 or 5 little holes, and those holes are shooting 90 degrees. Because my injector is coming through here, the holes are positioned so that they shoot flat across the top. So they're not flat to the injector because they would just shoot up here and hit the valve. I don't want it to hit the valve. I want it to shoot across the top of the piston, and I want to shoot it in all directions, as many directions as I can, so that I have a nice uniform dispersion of the fuel across the top of the piston.
So it kind of umbrellas out.
It'd be like an umbrella. And so if we have 5 holes are going to cover more area than 4. So the old inefficient ones would have less holes. Newer ones are going to have more holes, and they're going to be higher pressure because I want to atomize it, and the higher the pressure, the more I atomize. So I put more holes, smaller holes, higher pressure, better atomization. So it's going to go in. You can see if your piston were to come up too high, it's going to smack it just like you would like a spark plug on a gas engine. So it'd be important. You don't want to be setting this head down on a table with this injector tip sticking out. It's a pretty sensitive area. So would you take your engines apart, you'd want to protect that or pull the injector out to prevent that from happening. So that's 2 very different concepts between them. The injection pressures on a direct injection are going to be much higher than an indirect injection. So that's something that you should be reading about in the first 2 chapters where they talk about differences, advantages, and disadvantages, a lot higher pressures. So other than the injection system, the valves, the cooling system, that stuff on the 2 diesel engines are very similar. Another major difference between these 2 engines is going to come with the fuel injection pump. So this particular fuel pump or engine here has a unitized fuel pump. Each one of these units is one pump, individual pump. And it's running off of my camshaft. So I have a pipe that'll come from here up to the injector that I just showed you. Wherever I just put it. So it's going to come up to this injector. There's a single pipe that goes between them. And I have more than one pumping element. Inside of this housing is going to be a lever that attaches and actually controls. It's going to hook to this piece. So this little component that's on here is my rack. This is controlling fuel volume, which we're going to talk about with the sheets behind me, and we'll talk about with the components on the table. And so I'm going to have to adjust my fuel control rack so that each one of the pumping elements is exactly timed together. So John Deere has a 4-cylinder engine that has unitized injectors like this, and they have a system where they call run in the rack, and they run down, and you actually have to adjust the timing, the fuel delivery on each individual pumping element so that they all fire the same volume at the same time. And so there's a control rack that you would go down and adjust. So it's a little more work as far as there's something for you to do. If you were to take this engine apart, you would actually have to do that adjustments, and it would be important that you would follow the manual on that procedure, and there'll be a procedure on how to do it. So underneath this plate is some shims. fuel delivery timing is still done by shimming this thing up and down. And by shimming it up and down, how soon the camshaft pushes on it will be determined by the shim. So when I actually hit this and actually begin to pump it, determines fuel injection timing. So just like on a gas engine, we have a distributor that controls timing. This one we have shims that control timing of the injection. On a diesel engine, the timing of the engine is determined by the injection of the fuel. In a gas engine, timing of the engine is determined by the spark plugs firing. So that's the major difference between the gas engines we learned about and the diesel engines in this quarter. So we have shims. When I look at this engine, so kind of going back and forth here, this engine will have a unitized fuel injection pump, which means instead of having individual pumping elements, I'm going to have one fuel pump, and it's all in one housing, and it's going to be bolted in. This is not the one for this engine. This goes in a Yanmar, and this is a Mitsubishi, but the concept is still the same kind of setup, where they have a unitized piece that bolts in there. Underneath this injection pump will be a shim. So I have packs of these shims. You would put a shim on the housing and you would stick it on, and that determines fuel injection timing. So when you take your engine apart, you put it back together. If you have indirect injection, you would want to make sure that you time it, and there's a whole timing procedure in your technical manual on how you would set the timing, and it would be important. If you were to take this off, measure the thickness of the shim, put the same shim thickness back on, you'll find that your timing will be almost exactly right. So other than wear in the components, this shouldn't be off. But don't assume that just because this is what came off, that's what's right. You would want to do that testing procedure. So now instead of having individual pumping elements, we have individual pumping elements in the same housing. So they're still individual pumping elements, but each one of them is in the same housing, and then I'm condensed the control rack down to just one little bar. So instead of having a bar through the whole length of the engine block, I just have one control rack that's controlling all of the pumping elements.
This one is a little closer to going there.
Well, this, yeah, you're right. We'll use 3. So, but it doesn't matter. Even if I just showed you 2, here's a 3, same control rack. The only difference is now I have 3 pumping elements instead of 2, and they're all side by side. They're all connected together by the same control rack. When I move the rack, all of them move in unison. If I had this element, they're individual pumping elements. There's a rod that connects them all. The rods are all timed. When you move the rod, they all move in unison with each other. So you're still doing the same concept. So what I'm trying to show you is, even though we're very different, we're the same. So you notice that the injection nozzle on a direct injection is a fairly small, very cylindrical. Here's another direct injection. They call it a pencil injector. So I take the tip off, or the cap off, and it's got a real small little nipple on there, and again it'll have 5 very small holes. So this is a direct injection, very thin, because I'm trying to reach down between the valves and hold the valves. So I'll quit moving there. So I'm trying to reach down between 2 valves and be as close to the center as possible, but when I put something between the valves, what happens to the size of my valves? They have to go smaller. So I either have to go to 4 valves to go in the middle, or I have to go to 2 valves and I have to move the injector off to the side, and then I just change the hole sizes to try to get fuel delivery evenly across the top of the cylinder. So there's different manufacturers that have done different things. The injection nozzle for this one, you'll see that they tend to be much larger. So this is a indirect injection. Here's another indirect injection. So they don't have to be this big, but they tend to be rather large. And you'll see when you look at it, they're very flat. And there's a little teeny pintle sticking out of the tip of this, and there'll be one of those on here. So later we'll get a closer shot, you'll see that little piece sticking out. So if I took this and dropped it on the table and I dinged that up, I would ruin that tip of that injector. So, and we'll get more in depth into this.
So what's controlling the fuel pressure on there?
So fuel pressure, what's actually physically coming out of the injector itself, is controlled by the fuel injection pump. And I want to just say fuel pump because we have fuel pumps that are just transferring fuel. This is a fuel injection pump. So trying to keep the terminology, I'll try to make sure I stay that way. So this is a fuel injection pump. This determines pressure, duration, and timing of the fuel system. So that's all controlled in the fuel injection pump or the individualized fuel injection pump. So this is just an individual fuel injection pump.
It's not adjustable.
As far as
Can you change the pressure on it?
I can change the pressure. The actual pressure that it goes is actually determined in the injection nozzle. So I guess I need to clarify that a little bit. There's a spring inside of the fuel injection injector itself, and that spring determines opening pressure. And so I have a pumping element that's going to pump, control volume and timing really. And then the spring that's in here, when the pressure reaches a certain pressure, then the injector will open and inject the fuel. So the nozzle will control pressure.
So that's what they're talking about, nozzle opening pressure.
Nozzle opening pressure will be controlled by the spring that's inside of here. And I can change that, add shims or delete shims, and I can change that opening pressure. So when we get to actual injectors, start talking about injectors by themselves, there will be several tests, 4 tests that we're going to run. So we put the tester, we have a special tester for it, and I want to clear the air out. Once I get the air out, I want to know what opening pressure is. I want to know what my pattern is. I want to know if I have a drip. So as a drip test, does it actually leak? And one other test. I can't think of the test. And so there are 4 tests that you're basically running through. So, if the pressure, opening pressure was low, I would disassemble it and I would add shims. If it was too high, I would remove shims. So that would be stuff related to the injector. And we'll come back and we'll do more with the injectors.
And this is all controlled by the camera?
In this case, yes. This one has the main one cam. Your engine valve cam is also controlling the injectors. This particular one, the camshaft for the valves is on this side, and the injection pump is over here. There's actually a miniature crank camshaft that's controlling the injection pump. And I don't have an example of that. So it'll look just like the regular engine cam, but it'll be much shorter and smaller, and it's on this side over here. So the crankshaft, or the fuel injection pump, it'll have these rollers. So sticking out the bottom is going to be this roller, and that roller cam is running on top of a fuel camshaft. So, and it's just like same concept as you would for opening your valves.
Either one of these engines needs a glow plug.
It's really super duper cold outside.
Direct injection does not use glow plugs. Now it used to be I could say that no direct injection will have a glow plug. Today that's not true because the Power Stroke diesel is a direct injection and it has a glow plug. But it used to be common if I looked at an engine, if it had glow plugs, then it will be indirect. And we'll get more in depth. We'll have another lecture that covers some different parts of the engine. We'll get into the advantages and disadvantages. And with the pre-combustion chamber, which I don't have a cutaway to show you that, with the, I don't even have a glow plug out here. With the indirect injection, if you look at it, the glow plug is located right next to that hole. So this is where my glow plug goes in. Here's my injector. So the injector is going in one way, the glow plug's going the other way. A glow plug will look similar to this pencil injector, so I'll just use it as an example. And so when you look at them in the system, they'll be side by side like this. And what will happen is the tip of this one will touch the tip of the glow plug. So during cold start, when you hit glow, this will turn bright red, and then when this injects the fuel, it atomizes it across that hot glow plug, and it's creating a source of heat, and it's a point of combustion. It starts the combustion process. Once you start the flame will self-generate heat and continue to burn.
But unless it's really cold out, you don't really need it, right?
I don't need it, correct. So the two of them, if you actually look at it, they're going to be like somewhere like that. So just misses the tip of it. Is how it's situated. That's for indirect.
Heating the fuel, but on a direct injection, the glow plug, you're just heating the air.
For the direct injection, I will not have a glow plug. So if we want to swing the camera over here, we have an engine set up. This is a direct injection engine. It's got a different fuel pump that we haven't talked about yet. But instead of using glow plugs, we're going to use an intake heater. So this, if you look at this component that's here, it's got a little wire place for a wire to go on.
On both sides?
On both sides. So we have power in, power out. Now that they moved everything, I can't find anything.
When did we mess with those electrical? We messed with the electrical.
We did. I'm gonna.
So on your truck out here, are these tractors, when you turn the key and the little blow symbol comes on, is it one of these air heaters or a natural glow plug?
Most of our stuff out here has indirect injection, so they're glow plugs. But if I had an intake heater like this one, it would do the same thing. A light would come on in the dash and you'd wait till the light goes out, and I'm just heating it up. And this, if we were to look into it, it looks like a toaster oven in there. And the idea is, as the air sucks into my engine, I'm preheating the air so that I have a when I use my heated compression, because diesels do not have any kind of ignition source except for heated compression. As the piston comes up, it's got to jam that air together. When the air rubs together, it's like you're rubbing your hands. You rub your hands, you feel how fast it gets warm. Well, that air molecules are slamming together just like that, and you feel how much warmth you have in your hands when you just go. That's that friction of the air being pushed out. Well, that's what's happening in my engine, is I'm slamming the air together. And on the indirect injection, I'm slamming it all the way up into that little cavity. So you imagine I'm squirting it through that little hole backwards and compressing it. And then when I shoot fuel into that superheated area that was created, that flame will then flow back out. And so in this case, the air is going to go through. I'm going to preheat it, give it some heat. So now I have some heated air. And as I take that air and I cram it back together, it creates that thousands of degrees that will ignite that fuel.
I seen this video on Facebook about this write-up about the guy took I believe it was a diesel engine, and he made it run on water. Anyway, they arrested him for I don't know what it was about. It's no more heard about. But he made an engine run on water, and they didn't like it very much.
You'd have to really know what you're doing to try to do that, because there's no lubrication, and the lubrication for this system comes through the fuel. So the injection pumps and all that, if I ran water through, it'll seize up the fuel injection pump. So he must have done something fairly creative, which is not impossible, but it's you have to kind of understand what you're doing before you would decide to do that. So right now, because of our low sulfur and all the different changes we have with our fuel systems, lubrication is becoming critical and very important. And so the diesel fuel flowing through that fuel injection pump, and through the injectors is what actually lubricates all that system. If I use poor quality fuel, if I were to use vegetable oil from McDonald's, so I'm doing the whole biofuel thing, you got to be careful because that fuel that we're using, that biofuel that we're getting from the fry oil, it has to actually lubricate all those components. And if I'm not careful and don't do things right, it'll shorten the life of my fuel injection system. And the fuel injection system gets very expensive.
You should have an oil filter running. It's using the fuel to lubricate.
It's lubricating the fuel injection system, not the engine.
Okay.
So yes, I still have an oil filter, but that's just lubricating the engine. So I'm talking about the pumping elements themselves and the injectors. All those pieces are all lubricated by the fuel injection system. So this particular machine, direct injection, like we talked about, follow the wire hoses back, hoses go in, my fuel injection pump physically bolts in from the end. So I have a fuel pump that actually physically goes out. Instead of going down from the top like this other one, this one's coming in. There's a plate on this side, there's an actual gear, and there's a timing procedure. Instead of using shims, this one I physically rotated to get my timing. So there's a whole procedure that would time that. If I take this injection pump apart, which we're going to be doing for reasons that we shouldn't, but we're going to take it apart, and these are individual pumping elements. We have 4 individual pumping elements. If I open this plate up, you would find a camshaft. Bolted on the end back here is going to be what? What would be bolted on the end of this engine? That's going to be my governor system. So even though it's not a gas engine, I still need to keep this engine from running away, and I want to maintain speed. So this one will have a governor attachment on the end. If I had a cutaway or something, that's what you have. If we come back over here to this engine, what I don't see, or what I'm missing really, inside of here you see a couple of springs. There's some linkages and levers in there. That's part of my governor system. So this engine has a governor built into the end down here, all the pieces. You would do some adjustments and make sure you don't mess up your governor. Going to this engine here, we're also missing the pieces, but bolted onto the front and inside of here is a spring flyweight system, just like in the small gas engines. Flyweights fly out and controls that there's a governor system. So all of them have a governor system that maintains RPMs. And all of them, if you were to stretch the spring, all those things that you don't do on a gas engine, you don't do that on a diesel engine. So you don't yank on it to try to get it apart. So a lot of them, it's up here in this front bell housing. You would take it apart and make sure you don't hook it up wrong and all that kind of stuff.
Yeah, I ran across a second spring that I didn't know where it came from. It's on the floor. I was like, where did that come from? I went to go, I still can't find it.
It will be critical. So one spring will be involved in shutting the engine down, and one of the springs is a governor spring.
One set for start or something like that. And
So here are 3 different engines. 2 different direct injections, but very different. I mean, this got unitized injection pumps. This has a single injection pump. This one's timed by the shims. This one's timed by rotating it. Both of them have a camshaft that's pushing the plunger that's controlling fuel volume. Both of them have a rack that's keeping them all in time so that they all inject at the same time. So you can see there's a lot of similarities. This one has a governor system in the end. This one, the governor's built into the fuel injection pump. So they're accomplishing the same goal, but there are 3 different ways of doing the same task. And you just kind of figure out how did they do it.
freeze plant over here, didn't you?
Yeah, you've seen that. So what I want to do is kind of break down into, I want to get a little more in depth into the fuel injection pump, and I'm trying to do that today because we're gonna open that pump up. So the pump that's on this engine has been sitting for many years and it's varnished up, so we're not getting any fuel output from it. So to understand what we're looking at, which in the real world you would never take apart a fuel injection pump. You wouldn't take one of these apart and try to rebuild it. They're too complicated and the tolerances are so tight that we're not capable of doing it. So in the 20 some years that I've done diesel engines and played with them, I've taken apart 3 pumps. And all 3 of them were dead pumps. One of them I think is actually going to be this engine many years ago. And because the fuel injection pump was varnished up and the valve stuck in there, they were just simply varnished and stuck. So I was able to open it up, clean it up, put it back together, and it worked. And I basically just freed it up. If I could somehow get a cleaner to go through the injection pump and let it clean itself up, it would be better. So if it would work a little bit, we could run cleaners through and actually make it better, but this one doesn't do anything. Another one that I had, the oil in it was so bad. It had gotten so gritty and nasty that the grit from the oil had stuck the plungers at the up position. So the cam was turning, but it wasn't actually pushing on the plungers. So I took it apart, I cleaned it, and I put it back together and I got it to work. But really shouldn't do that. The time that I spent, I couldn't do that for a customer and make it pay. So if I were to take this injection pump, if it was complete, and I send it down to our local diesel repair shop, which we are fortunate to have one locally, it would be $800 or $900 to have this rebuilt. If I sent the one that's on that engine down and they were to rebuild it, it would be somewhere between $800 and $2,000. A new pump would be somewhere between $800 and $1,200. So it costs the same to get a brand new one or to have them build it, and it'll be virtually brand new when they get done rebuilding it. So they don't put it in their machine and actually test it until they've taken it apart, cleaned it, and rebuilt it. So if you took that injection pump off because you thought that was a problem and it wasn't the problem, but you sent it down there, they would disassemble it, they would clean it, they would rebuild it completely, and then they would test it, recalibrate it to make sure everything's calibrated perfectly and send it back to you. You bolt it back on. If that wasn't the problem, you still don't have a working engine, but you're still $1,200 in the hole. So you want to make sure when you decide that the problem is a fuel injection pump, you better be comfortable and confident that's what the problem is. So don't just assume that. The tolerances, we're going to look at this. This is the pumping element that actually pumps the fuel. So the very inner part of this fuel injection pump is this element. These 2 parts are a 0 tolerance piece. If I were to sit here and while I'm talking to hold this part in my hand and it was a good part, when I go to put this back in, it wouldn't fit because the heat from my hand would expand the metal enough that it would not fit in here. So I would not want to be doing that. I'd want to have this in diesel fuel. I would take it apart. I would actually work on it in the diesel fuel in a dish. I wouldn't be out here on a table like this. I would never try to assemble it dry like this in my hand because I want that lubrication. I want to make sure that I'm washing any dirt that might be floating around. I would wash it off. You have to be beyond ultra clean when you deal with this. Your hands would be spotless. I mean, having dirty hands like this would be like, you just wouldn't do it. So you would have super clean, your hands would be clean, you'd put gloves on, you'd have clean diesel fuel, your components would all be clean, and then you would put them in the fuel, you rinse them in the fuel, and then you would assemble it in diesel fuel so that it's all clean and lubricated. Now, I'm making it fall apart here. So I think what I'll do, I think I'll go up to these drawings up here. We'll talk about the theory, and then we'll go back to the reality on the table. So this is the fuel injection plunger. That's actually what's determining how much fuel is being delivered to my injector. So these are the processes that it goes on. And then depending on where I set the rack that we talked about earlier, how much delivery takes place. So these 3 really are, I could put those in place of this middle one. So we'll just start down here on the end. So the plunger that's there, that's this piece that I had in my hand. This part is the one that's in the middle here. So I have a plunger, this is stationary, and this part is going up and down determined by that roller cam and the camshaft. So every time the cam goes around, it's going to be pushing this part up. And the pushing up, the distance that this part moves is the same every single time. Because it's running on a camshaft, the camshaft always plunges the exact same distance. So it's going to go from bottom dead center to top dead center. This part is going to go the same. The difference is this helix that's in the middle. And I have a rack, which is going to be something with teeth on it. So I have a rack that's going to be on the bottom, and the rack is rotating. So this part will rotate but go up and down the same distance. The rotation of it determines no delivery, partial delivery, or maximum delivery. So how this thing here rotates determines that. So at this point, my plunger is all the way at the very bottom. Yesterday when we were playing with this system, we purged all the air out. Basically what we were doing is flooding this entire part, the top part of my injection pump. So this is my fuel inlet. This is the little screw that we would open to bleed the air out. Once we get the air out here, then the fuel goes inside. This upper part of my injection pump is flooded with fuel. I want no air in there. And it's just filled with fuel. Slightly pressurized, filled with fuel. The plunger will be down. There is a hole that's on the side. So when I rotate this, you can see there's my hole. If the plunger is down, this cavity of fuel pushes on that hole and fills the cavity on top. So this cavity up here fills with fuel. If I want a no delivery system, you'll see that there is a slot, a notch, and you'll see it on the plunger here. This little notch is what I have right here. That notch will line up with this hole, and with no delivery, when the notch lines up, is this plunger goes up because the camshaft pushed it up. This fuel, instead of building up pressure, just squirts back out into the reservoir, the cavity that's there. And because it's not developing any pressure, just pushes it out, I get no delivery of fuel. So you pull the lever, or our electric solenoid turns off and the rack pulls all the way back. It's rotating this plunger, no delivery. And that's what shuts your engine off. I start it up, I rotate the rack away, the plunger starts to come up. If the plunger is rotated and there is a solid piece of metal here, when I begin in delivery, this plugs that hole. It cuts it off, it blocks the hole, and when it blocks the hole, fuel can't go. These stuff that's all in red is all captured fuel. This injection plunger is going to be continuing up. As it's traveling up, it's got this fuel captured in here. I have a heavy spring and a check valve. I will push the check valve off of its seat, push the spring up, and I will push fuel up into my fuel line. If I had my fuel line off, the fuel would just come out. It'd be at low pressure, it would just come out. If I have my fuel injection line on and I have an injector on the end, then the spring or the injector would determine how much pressure would build up before the injector delivers the fuel. So delivery, from the point that it shuts it off until we hit this helix, will be delivery. So I'm going to continue to deliver fuel until the helix that's coming down lines up with that little hole. When the helix lines up with the little hole, it stops injection. So at this point, as soon as the helix lines up with the hole, it relieves the pressure. My spring pushes the check valve, it stops it from delivering anymore, and I end injection. So at an idle, at partial delivery, I'm barely going to come up, and I'm going to meet that point, and boom, I dump it off. Stop delivery. Maximum delivery, we would rotate it, and the maximum distance that the plunger travels before it dumps would give me maximum delivery. So it's a pretty simple system. And they're all these systems that I just showed you are all going to function in the same way. So end of delivery is whenever the helix lines up with the hole, top dead center, so you see the plunger just keeps going up until it tops out, and fuel is just, nothing's happening. So that's your mechanical system. You have a rack that's in the back, so no delivery, partial delivery, maximum delivery. I'm just moving that rack back and forth. That was the little rack that we have here. So as I move this rack back and forth, I'm physically rotating the plunger. As I rotate the plunger, it allows more or less fuel to be delivered before it's dumped off. Does that make sense?
Yep.
So Sean, that makes sense?
Yeah.
So it's a pretty simple system, and we're going to use this same system in all of these blocks that we have here. Whether I have a unitized injector system, if I were to take this one apart, it's going to be the same way. So this is my rack. This is my rack that comes here. I just have an individual rack instead of one rack controlling all of them. And then the plunger is going to be going up the same distance. Inside of here would be the hole. So I have fuel coming in, and it's surrounding this area, cavity, keeping it full, and then it sends it up through the top. This one that's over here, when we take it apart, we have individual pumping elements with our camshaft that's in the bottom. When we take this piece out of the top, we're going to be looking at the same thing as I just showed you in my hand there. So individual pumping elements in here. The problem is going to be when I take it apart, there will be a bunch of little brass washers. So we have different kinds of sealing rings. There might be O-rings, some kind of sealing thing in there. And if I'm not careful and I crack that open and try to retighten it, if I don't replace the O-rings in those copper washers, once the copper washer is squished down, they don't expand back out. So really, if you disturb it, you need to take it apart, put washers, copper washers, brass washers, whatever kinds. Some of them are aluminum, and you would replace them and tighten them back down, and it's like a one-time shot, and you're done. So you don't want to disturb them once you're done. So looking at it, if I were to break it apart, here's all the pieces in a row. So I have a roller rocker. This is a piece that's running on the camshaft. Inside of that is a piece that runs on the roller ball, so a surface to run on. It has a notch in it. That notch clips on, and that's what forces this plunger to move up and down. So oops, I kind of came out of it. So that's what's actually making this go up and down. There's a spring in here that also is keeping it on there, but I don't have the spring on there. The piece with the teeth on it, that's my rack. So you'll notice that the plunger is running in a slot. So as the rack rotates, it causes the plunger to rotate. On top of all that is the area that's determining the amount of fuel being delivered. On top of that piece will be the check valve. So we have a component with a check valve. So it's just a tapered component that would sit in here, and that's what shuts the fuel off. Actually, it goes on there like that. So it goes in here. This is going up and down. We have a spring, and the spring is what you've seen on the picture up there. The spring is on top, so it's holding tension. And so the minimum pressure it takes to open this up is determined by this spring. This spring is a lighter spring than the one that we'll find in our injection nozzle, but it does put some pressure on it. And then we just have the cap, and the cap is what's holding all this in place. There's a O-ring in here, and there may be some other sealing washers. That's what we're talking about that needs to be replaced. So this is the element that we would find sticking out of the top. So at that point, we go from there to our metal pipe. What you'll notice about the metal pipes is all the metal pipes, if it's a 2-cylinder, 3-cylinder, 5-cylinder, 8-cylinder, no matter how many cylinder it is, this length of pipe will always be the same distance. The reason why is because in order to get the injection the same in every cylinder, if I had a long pipe versus a short pipe, well, it does, and it has to do with the small amount of compressing that happens within the fuel. I want all the injectors to get the same amount of compression. If I have a short one, it would compress less than a long one. And so they're all the same length. So you'll see a lot of them, they zigzag around, and that's just to kind of take up space until they get to the injector itself. If you zoom in and look at this, you'll notice that these pipes, they're a small pipe, but the hole in the center is teeny. They're really thick piece of metal with a very small hole, partly because I don't have a lot of fuel that I'm delivering. I don't want to have a lot of space to expand on. They're developing a lot of pressure, and I don't want to blow the pipe. But even though we have such a small hole, this pipe still expands every single time that this thing injects fuel. And we have a tool that we can check timing with called a piezometer. It clamps on here, it measures that metal pulsations and turns it into an engine timing. And so we'll be seeing that later on. So that's all of my components inside the fuel injection pump. Over here, this pump mechanism, this pump mechanism. These would be fuel shutoff solenoids. Fuel shutoff solenoid is simply a plunger that's moving in and out, and that's just moving my rack. So I would hook it here and I would shut the rack off, no delivery, or turn the rack on, and I would have partial delivery. So we do that in several ways. Looking at my nozzles or my injectors themselves, lots of different ones. If I have indirect injection, typically on the bottom is a heat shield, and it would go right, and this is actually in the bottom of that head. There's a piece in there that you would take out, and it's the heat shield, and it's trying to transfer that heat out into the body of the head rather than putting it into my injector.
It's a couple thousand pounds per square inch.
So these injectors, they're all direct injection. Direct injection, you can rebuild the nozzles pretty easily, and really all you need to buy is just the tip. So you buy it, they come in a little container, and you buy just the tip. This tip is about anywhere from $35 to $60, $70 for this tip, and this is a bad tip. So this is a bad one, and it's bad. I should be able to pull this out, but I don't. So when you get them, they come in a container. The container is full of diesel fuel. So it will arrive to you bathed in diesel fuel. If you were to take it out, you have the pintle and you have the injector tip. So you can clean these with a brass brush, and that's it. You cannot use a wire brush to clean your injector. This tip, if you look at it in your book, it'll show you the tip isn't cone shaped. It actually goes out a little bit, and that out will actually define and what gives it that conical shape. So what causes a diesel injector to actually open up? If you open it up, you see how it's tapered here. So what's happening is the diesel fuel is coming down beside this. It's actually pushing on that taper. And when the pressure gets to a certain amount, determined by the spring that's on top, it'll actually push this plunger up. So this plunger is what comes up. As it comes up, the fuel goes around it and injects into the engine. So this is the piece that moves. If you were to hold this in your hand and then try to put it in, it won't work. That's how tight it is. So you would not take a wire brush, you wouldn't sand it, you would test it. If it tests bad, you typically just replace it. And that's all, it's just this part. So you would disassemble it, change the tip, and put it back into a fuel injection nozzle tester, and you would check drip, opening pressure, and drip, opening pressure, pattern, and and then it should squeak. They typically have a screech to them, so you're listening to the sound and how well it atomizes. So they're pretty simple to rebuild. Direct injection, this style here, this particular one, we can take the cap off and you can also replace the tip on it. Oops. It has a little bit wider one, so I can replace the tip on them. The pencil injector that I showed earlier, this style, a technician can't really rebuild. You can send these to a diesel repair shop. They have some special tools. They take it apart, they take the pieces out of the middle, and you can buy rebuild ones of these. But typically, you would just buy rebuilt ones. You don't rebuild them yourself. So, and they're less than $100, I think.
Pictures.
So they're not super expensive. It's not like a major expense. It's kind of like changing really expensive glow plugs or something. So the injector stuff is not the expensive part. If I were to buy the whole entire piece, I didn't realize I could buy the tip and I buy the whole nozzle, then we're talking $100 plus $200. So why buy all this metal that never wears when all I need is the tip? If you were to replace just the tip and take it apart, then inside there is a heavy spring, and on top of that spring is a set of washers. And oh, here's one that's apart. So here's what it looks like apart. There's a spring that goes inside. It's not the right spring. So I don't have the right spring for this one. So there's a spring in there, and then in there is also some little teeny washers. And those washers are what determine the amount of pressure holding that pintle from coming up. So you change that spring tension to determine what pressure it takes to open this up. You can buy the washers. They sell kits that have various shim thicknesses. And your technical manual tells you what thickness, how much pressure each shim changes. And so you just look at the chart, measure it, change it, recheck it. So not a big deal. And this is the same way. This one here would be rather expensive to buy the whole piece. You just unscrew the part, change the nozzle and the tip, put it back together, retest it, make sure it's shimmed right. So not super complicated. Earlier we talked about pre-combustion chambers. These are two different kinds of pre-combustion chamber. This one here has just a single hole. If you look at this side, it's just smooth. This one is more like the Kubota one that you're reading about. It has a different kind of chamber, and then on the back side here you'll see it has a large hole, two smaller holes, and then a very small hole. And so this is going to be sitting on the side of the hole. So here's my piston. It's going to be off to one side. I would have the largest hole shooting across the largest area, and the little hole would be the bottom part of my cylinder. So the number of holes and where they direct them, as the diesel engines have gotten more efficient, a lot of it has to do with how they machined and how they altered this piece. So that was a major change. So they talk about hybrid pieces in there. That's this piece.
To make sure you put it in right.
There's a little bump right here that would keep you from putting it in wrong. So yes, the orientation is determined by that pin. So other pieces that are on this table, this is a fuel heater. So old style engine, our 650 tractor out here, this sits inside the intake manifold. Instead of having one of those pancake heaters, it has this contraption. You hold the lever into glow for and it's like 60 seconds. And electricity will go through this wire, heats up the coil that's inside. So inside of here is a coil of wires. It'll get glowing hot red. And then on top here where this black cap is, there's a line that goes up to a little cup. And the cup has diesel fuel in it. And it will dribble diesel fuel down on this little wire and when it gets hot enough, it just catches on fire. So inside your intake manifold is an actual flame. Starts on fire, and then when you crank the engine over, it pulls that flame and the heat from that flame into the engine. So it's heating the intake manifold with a fire, physical fire, and then when you crank it over, it pulls the heat into the engine. What would be the problem with that system? Why would it be bad to be sucking a fire into my engine?
Burning the valves as it's coming in.
Doesn't get hot enough to actually burn the valves. But if I have flame, what's the flame doing? It's burning oxygen, and it's creating soot because it's not burning very well. It's inside this metal intake manifold, so you can see it's going to be kind of sooty. You can have a lot of partially burned stuff, so I got this soot that's being created, and then I'm sucking it into my engine. So I got this partially burned lower oxygen cavity of air that's traveling in that I'm trying to shoot fuel into and actually burn. So it worked. It's better than nothing, but they've abandoned it because there are better methods. So the pancake heater doesn't create the soot, doesn't have the flame, leaves my intake manifold full of fresh oxygen, clean air, and allows that to go in. So you can go out here to that little 650, take the hose off, hold that in glow and watch in there. All of a sudden you'll see a little fire will show up, and when you start it up, it'll go away. And that's what this is. This piece here is a fuel heater, so this goes in the fuel filter, and I'm preheating the fuel before it goes to the fuel injection pump. And so the idea is if I have warm fuel squirting in there, I'm not pulling the heat out of the air to warm up the fuel. So if I can preheat the fuel before it's injected, it just gives it an added ability for cold starting aid. So it's kind of another type of cold starting aid where they actually heat it up. So there's lots of things out there, and these are just two of them.
Doesn't that affect the fuel flow if you heat it up and it expands a little bit?
Well, it will expand a little bit, yes. But I want to heat the fuel up so it flows easier, so viscosity will go down. And we're talking about cold. So in cold, it's too thick anyway. It's not flowing very well. And it's not atomizing super well. And it's not going to burn. So we wouldn't be running this in the summertime. This is our cold starting aids only for winter time where I'm struggling to get enough heated compression or fuel temperature to get it. So these are all cold starting things.
Bringing it up to room temperature, like 60
Yeah, it'll be bringing it up. And I don't know exactly what the temperature is, but it's pre-warming it just to make it flow easier and atomize better.
in the fuel tank or the
This goes in the fuel filter.
little,
It would go in a different kind of fuel, or a larger fuel housing, and it goes in the fuel filter.
being the same piece?
Right, as the filter itself.
Okay.
So lots of variation. What are we trying to do? We're trying to make the viscosity go down. We're trying to heat up the fuel so it atomizes better. We're trying to heat up the air so that it takes less heat to heat the air up. We need to reach minimum cranking speed, because minimum cranking speed determines, it creates enough heat to get enough minimum heat of compression to ignite the fuel. So all of them are trying to get minimum cranking or heat of compression to ignite that fuel that's going in, because I have no spark. It has to have heat from the air compressing together. So I preheat the air, I heat the air within the cylinder, I put a glow plug that's a hot point, I use some kind of fuel heater to heat the fuel up. Here I'm actually lighting the air on fire, trying to create some heat. I plug my engine into the wall and I heat the cooling system, which is heating up the cylinder walls, gives me more warm air before I compress it. All of those are trying to bring that heat of compression up to reach the minimum to fire off the engine.
On that 3 hole in there.
Four.
The big green one.
Well, this one, yes.
Yeah, where's the fuel coming in there?
The fuel is going to come in right here.
Okay, and
So just like this one here,
going into a chamber inside there.
there's a chamber in here that just surrounds or floods all three pumping elements. So there's a cavity. What keeps the fuel from running through and out the bottom is just the precision machining of these parts. So if you were to take this apart, scratch it all up, put it back together, fuel would actually leak past, get down in here. This cavity, as you see from here, is just inside the engine. So you'll start getting fuel dilution within your oil because it would actually be leaking through. So if you don't replace the little sealing washers and it leaks, and if you're doing oil samples, it would show up in your oil sample.
So that chamber is the orange area.
That chamber is this orange area right here. And you gotta remember, it's like three elements side by side, so this cavity.
The thing that can obstruct fuel going up into it is if it varnished on that.
If it varnishes and this plunger sticks in the up position,
Yeah, that's the only thing that would probably.
and that's what's happened in the past, either this engine or a different engine like it, is this plunger is all stuck in the up position, and so no fuel would come out.
And then where was the return line? The bypass that goes back into the fuel tank?
And this particular engine here, this fuel pump, does not have a return to tank.
Oh, really?
No. The engine that you have, there's a return to tank here. So if the flow gets too high, it returns back to the tank.
So what if that one varnishes up then, or whatever? It has no way of letting off excess fuel?
Not from inside. This one just has a line that comes up to it. We can bleed the air out, so I could purge bad fuel out if I wanted to. I could purge air out and then thread this back down. But once it gets inside of here, I can't really purge it out of there. I would have to crank it over and try to pump it. I could take the lines out, try to purge it up through there. But if nothing's coming out, then I had to pull the pump and send it off to a repair shop.
So how long does it take diesel fuel to actually varnish?
It usually takes several years.
A long time.
Yes.
You're not usually going to leave it sitting
Most of the time it just gets really stale. It doesn't burn very well, but it doesn't varnish up like a gas engine would just varnish up and goes away. Because diesel fuel is much more oily, it doesn't do that as often. So the engines that I've had do it, the other engine, it sat for like 8 years and it just stuck. So, and this engine hasn't ran for probably 8 years or 10 years.
If you put gasoline in there, what would happen?
If I were to put gasoline in a diesel engine, first of all, gasoline has no lubrication value. So these plungers that we have, it's all lubricated. That movement that we got here going up and down is lubricated by the diesel fuel. If I remove that lubrication, I use the wrong kind of fuel, ultra low sulfur fuel. Sulfur was the lubricant. So some of these fuels that we're using, I lose that lubrication, and then I actually will get fuel. Instead of being controlled by this little hole, now the fuel will actually leak past the plunger and back out into this cavity. So I get reduced fuel flow as it starts to wear. It could wear because I'm using the wrong kind of diesel fuel, or if I use gasoline with no lubrication, I'll start scoring, and this thing could score and stick in the hole.
Also, a diesel engine runs on more air to fuel ratio than a gas engine too, right?
Higher air to fuel.
Yeah, higher air to fuel.
Yes, it is. But the first problem with gas is going to be scoring and damage within the fuel pump. The second problem is once I get to the injector, again, the injector has this pintle. This pintle is lubricated by the diesel fuel. So now I have no lubrication here. I'm going to have damage here. And the most important and the worst thing is the temperature at which gasoline ignites is way lower than diesel fuel. And so now I start to inject that gasoline into the cylinder, and as it just begins to come out, I'm going to ignite it, and it's going to flash, and it burns so fast and so hot that it will actually start melting and just blows your head gasket, it blows the tip off the injector, it just severely damages the top of your piston. And so it's a very dry, volatile, hot, damaging flame that's so fast and so violent that we've determined, pistons traveling up on the heat of compression. As it goes up, we're going to inject fuel so that when it gets to 10 degrees after top dead center, which is exactly like a gas engine, so I'm going to inject it at a point to where when it gets to 10 degrees after, that flame reaches maximum expansion and pushes my piston down. Gasoline, piston's coming up, I inject fuel, boom, it reaches maximum expansion, the piston's still traveling up, and you get that violent knock, and that violent slamming, it breaks piston rings, blows holes in the piston, it just destroys your engine. If I were to use ether, same thing. I'm shooting ether in my intake manifold, ether goes in, piston's traveling up on heat of compression, it's getting hotter, hotter, hotter. As soon as it gets to the point that the fuel mixture is going to ignite, it ignites. So if you're one of those people that have ever shot diesel ether into a diesel engine and cranked it over, what does it sound like? It's like knock knock, and sometimes it'll actually stop the engine because piston's traveling up and then it expands and it goes, and it'll actually hydrolock it up. And so
all the time, the loader over there, Stubblefields, sprayed it into the air cleaner.
How long would it take the gasoline to destroy that?
I think it doesn't take very long. So the people that I know that have actually put gas in a diesel engine, they don't get very far from the service station before it goes.
Will gasoline even start with off the road? Just off that compression?
Gasoline will ignite because the temperature that's created in a diesel is so high, it will always ignite the gasoline, yes.
Well, it did that once years ago. They didn't tell me it was a diesel engine on a forklift, and they said to fill it up before I brought it back, so I put a couple gallons of gas in. Not very much, and I didn't use much, but I got really leaned out good later.
So
Because I mixed the gas.
that's the next thing that I was going to talk about was really the volume. I mean, if I put straight gas, it would be a matter of a couple of minutes and it'd be destroyed. If you were to put a little bit of gasoline, let's say you put a gallon in 25 gallons of diesel, it probably would burn it through. If you were to put a little bit of gasoline into diesel fuel in the winter time, it would aid because it would ignite a little faster. It would actually aid in your cold starting ability. The problem is how much? What is too much? What is too little? And so because you and I are not chemists and we don't know that, and because the engine is changing temperatures as it's warming up, playing with that little volatile mixture and trying to do that is not a very wise thing. If somebody topped off a diesel engine, it had 100-gallon tank and they put in 10 gallons, if you just drained most of it out, put more fuel in, and then diluted it down with other fuel and some other system, you could burn it through and it would be fine. I've had a student, I didn't have a student, I had a student work for the grounds department, and another employee filled the Toro mower he topped it off with gasoline. So it was probably 50-50. And he went out and mowed. And he mowed for about a half an hour. And the longer he mowed, the more it smoked and it knocked. It made a lot of bad sounds. It ran really bad. And he just kept mowing until it just got so bad that he kind of finally shut it down. Student went out there, looked at it. Oh, and they found it, yep, you put gas in the diesel. And then my student had the guy start it up, drive it back to the shop. Thinking, as soon as you find out, don't start it up. Leave it off, tow it to the shop, put it on a trailer, haul it somewhere, drain as much out as you can, put in new fuel, get it started again, and let that cycle through, and then see if it still runs and what damage was done. Don't start it and drive it to the repair shop to get it fixed. It's like, stop the damage now. So that I've had that happen twice now, so it's bad. As soon as you know, stop, quit. So I've had several occasions where I know people that have put diesel in gas. If you put diesel in gas, depending on the ratio, the higher the concentration, it smokes horribly. I mean, it looks like your machine's on fire. And it'll knock and it pings and makes horrible sounds. Same thing, drain it all out, get the gas through again. And it usually doesn't damage too much. It's rarely that it damages it. But gas and diesel, too high a ratio, it will damage it and it will cause...
Another book is saying a diesel fuel has more energy.
That's true. Diesel has way more energy per gallon than a gas.
But it burns slower.
It burns slower.
But if you mix it with a little gas,
It will burn faster if you mix it with gas.
and your gas engine, it has more energy available with that.
It has more energy. So if you added a little bit of diesel to your gas, you would probably get a little, if you did it correctly, you would get a little more fuel mileage out of it because it has more energy per gallon. The problem is it burns slower, and so your timing of your engine, everything is for the volatility of gasoline.
Change your injector to put less in there.
Your computer with new computer stuff might compensate for it, but you have so many emission things that you just don't want to do it.
So what's controlling the fuel on here? Because some of them are saying they monitor the temperature of the combustion chamber, the air temperature of the fuel, all this stuff, and all adjusting the fuel flows and all that. What is this thing controlling that with?
The new cars, pickups, big trucks, that kind of stuff, diesel engines higher than 45, 50 horsepower, typically higher than 70 horsepower, have gone to electronic monitoring and that kind of stuff. And they'll do electric, instead of a mechanical injector, we use a solenoid control injector. So I have a computer, it's monitoring engine speed, engine temperature, air temperature, all these things, and it will determine when and how much. So your power strokes, and that kind of, they're electronic fuel injection system. Physical solenoid, each injector is like $1,000. They're really expensive because you have, a very precise, very high quality electric solenoid. Some of them use oil pressure to actually inject and fire the injector. So I use an electric solenoid to time it and high oil pressure to actually move it, and then the fuel is injected in. Those are very expensive injectors, but they're computer controlled. This one is all mechanical. I don't have to have any electricity at all to make this system work. All I have to do is get the fuel system on. If I have an electric solenoid shutting it off and on, all I need is a string and a wire, put it on here, and I'm going to wire it in. And what did I do? I just opened up the rack, and now it will run. You crank it over, it's going to inject fuel, it's going to start and run. At the end of the day, if I want to shut it off, I undo the string, shut it off. So my brother has a Dodge pickup, Cummins engine in it, and his solenoid burned up. We put a new one in, 2 days later it burned up. So it has some other wire issue that burned up the solenoid. So he was outside my shop, it burned up out here on the highway, driving along, all of a sudden, smoke rolled out from under the hood, and the epoxy all caught on fire. So anyway, I just called me on the phone. I'm like, just take a string, wire that plunger up, bring it to my shop. So we brought it here, we cleaned it up. I actually took the solenoid out completely, threw it in the back of his truck. And without the spring and everything on here that's kind of giving me tension, now it's like, it's just like moving this rack. There's no tension on his at all. And so I just built this little wire thing that when he starts his truck, it starts up. When he gets to his destination, he opens his hood, he reaches under there, he pulls the wire off, he pushes the plunger down, the engine dies. He pulls the plunger back up, rehooks it, closes his hood. So when he gets back in, he just starts it up.
How much does the solenoid cost?
From Cummins, it was $600 and some dollars.
Yeah, I bust out coat hanger too.
So he went to Wendland Diesel. He got one that was $300 and some dollars. I found one on eBay for $56. Big difference. So anyway, but the problem is we got a new one, but I can't put it in until we solve the problem. You notice there's 3 wires. One's a ground wire, one's a pull-in winding, and one is a hold-in winding. So the pull-in winding is a high amperage wire. It goes anywhere from 10 to 30 amps, and it will pull the plunger up in there. And then the hold-in windings is usually around 1 amp. And the hold-in windings will hold this in place. The hold-in windings can't pull it up, it's not strong enough. So you have to use a high amperage to get it there, and then the hold-in will keep it there. Well, in his truck, what's happening is it pulls it in, the hold-in is holding it, but then he's got a wire that's shorted somewhere. 2 wires are melted together, and he's getting back feed through the hold-in windings, and it intermittently, you're driving along, all of a sudden it'll energize the hold-in, so it's pumping 20 amps or 10 amps or something into it. It's trying to pull it in what's already in, and it just keeps doing that until it catches on fire and burns up. So it's a random thing, because it ran for a couple of days before all of a sudden.
Ended up heating up and touching inside.
So what we need to do is we have to cut his wire loom apart or just run a new wire. But somewhere he had a fire or some kind of electrical short, and his wires have melted, and he hits a bump. And so I put a meter on it. I put a meter on it, and I wiggle his wire loom around, and the voltage was 0.9, 0.1, 0.87, 0.8, 2.7. So the voltage, which is not supposed to have any voltage, he's got voltage there all the time. And as I wiggle his wires around, the voltage changes. So somewhere in there the wires have melted together. There might be one strand touching, but it's energizing this. And if you energize this hold-in windings for more than 30 seconds, you will release the smoke from it. So it doesn't take very long. In 1 minute, if you hook this up and held it for 1 minute, this thing would be so hot it would burn your hand. So you do not want to energize that hold-in windings for very long. And that's true, there's like a lot of different kinds of these, and all of them, if there are 3 wires, you want to make sure you're not hooking up the wrong wire. So if you hook it up wrong, it won't turn on. If you hook it up wrong again, it stays hooked on, and then it burns it up. And all they're doing is pulling this rack, rotating it so fuel can be delivered. Yeah, well, there's a great example there. So if you shine it on this engine over here, can you see the solenoid? So let's say this went into a lawn tractor, a lawnmower, or a tractor. If it was stranded out there in the field, and I knew that my fuel injection thing or my fuel shutoff solenoid was bad, well, let's say my something in my wiring system was all screwed up. All I have to do is unbolt that thing and take it out, or screw it, move it outward, and then I could crank the engine over, and that would turn the fuel on and it would start. So years ago, this would be like 12 years ago, I went to Portland and we bought, I think, 7 fairway mowers from the John Deere dealer. They were Toro fairway mowers that we bought from the John Deere dealer. All of them were sitting out back. They were trade-ins that they took, and then they were John Deere dealer, so they didn't want to sell the Toros. So they just kind of didn't know what to do with them, had them sitting there. So we bought them pretty cheap. And all of them had bad batteries in them. All of them were missing keys. The keys were bad. The wiring systems were all screwed up because of the weather. A bunch of them had berry vines growing through them, and it was pretty nasty. So I just physically hooked onto them, pulled them out of the bushes. I took a jumper pack with me. I hooked a jumper pack to the starter. I used a push button to crank the starter over. I backed this fuel shutoff solenoid out. So I physically screwed it out 5 turns, which turned the fuel on. And then I just cranked the engine over. It had a mechanical fuel pump. I used a jumper wire, and I activated the glow plugs. Cranked it with the starter button, started it up. They're hydrostats, so then the hydraulic system was working, and I drove them up on the trailer, climbed back inside, threaded that in, and it shut the fuel off, got him to school. So I started all 8 of them without a battery, really. I used a jumper pack to keep them functioning, and once I got it started, I actually disconnected the jumper pack because I didn't need to run anything. It was a diesel engine running hydraulics, so I was able to just disconnect my jumper pack and drove them up on the trailer, disconnected them, and loaded them up. And so here's a machine that actually has a computer on it. The computer is controlling all kinds of functions. And I got it loaded up on a trailer and delivered them to Walla Walla Community College, simply because I understood how the system worked and what I could do. So I didn't have, it's a solenoid, electric solenoids that lifted the reels up, so I couldn't lift the reels up. And I just took straps and I lifted the reels up with a strap and just wired them up. So I did all that kind of stuff, and then hydrostat, I just drove them up on the trailer. So I was able to bypass all the electrical operated stuff simply because I knew how it worked. It's all mechanical except for this electric shutoff. And it allows you to turn a key off and shut the power off. So if I have an emergency and need to shut it off, just boom, shuts off. Before the electric solenoids, everything had a physical lever. You'd pull a rod out or move a lever, and it would mechanically move that rack. And I could actually remove that solenoid. On my brother's pickup, I could actually run a cable out of his cab, through the cab, and hook it to that, and he could just pull a lever, and it would shut the fuel off, and then shove it back in, and he'd start up. So he could actually set it up pretty quick, and never, well, I could just snip that wire that's screwing them all up. I could snip the wire or disconnect that wire, and when he shut his truck off, it would die. He would have to pull a lever to turn it off. He'd pull a lever to shut it off, and then he'd shove it back in. It would start right up every time. And I could set his up to where he would never get out of the cab, never have to open the hood. But we're just going to try to solve it. So rather than cutting into the system and screwing it way up, we'll solve it. So, but that's because I understand how the system works. So it's not complicated. It's not, but you just need to be aware of what it is. So if you read your book, hopefully now when you go back to your reading will make more sense. You'll see that there are several chapters in the black book that get into the fuel injection pump. The pumps themselves are very precise, and it's not because it's too complicated for you, it's because you don't have the instrumentation to make it that precise. So without the testing equipment that measures ultra fine, what are you going to do? And so don't really attempt to take a fuel injection pump apart. It's just determine everything else is fine. You have good compression, you have good fuel injectors, you have fuel delivery to it, the timing is right, everything else is right, it's still not right. Then you take the pump, you send it in and have it rebuilt. And in the case of these, I found that price it both ways. It costs the same amount to rebuild it as it is to buy a brand new one. It doesn't matter. Either way, it's going to cost you almost the same price. So this style, it would pay to send it in and have it rebuilt versus buying a new one. Because it has the whole governor system and everything on it, it would get very expensive to do that. So the important message with diesel is don't screw it up by putting bad fuel. Make sure that your filtration system is correct. Make sure your fuel lines don't get holes in them and you're sucking air, because air doesn't have any lubrication. Air is going to take it out. Bad fuel. I had a guy that wanted to save some money, so he took his waste oil and he mixed it in with his diesel fuel. So he's kind of making a percentage to extend the life of his diesel fuel. Well, you take used motor oil. What's in used motor oil? Carbon deposits, acids. I mean, there is lots of bad stuff in used motor oil.
My boss did that all the time.
And he put it in there, ended up wiping out his injectors and his injection pump. So he saved a little bit of money for a short period of time. Then he bought a $900 pump. And he spent, I think it was a 3-cylinder engine, so he had $100 and some in injectors. And he had to buy a new filter, change his filter, he had to flush it, change his lines. By the time he got done and he paid the guy to do it all, he didn't save anything. So mixing used oil, I mean, if you're going to use brand new oil, say you got some cheap oil somewhere, I could kind of see someone doing that. But the problem is motor oils are designed not to burn. We put them in a hot engine, I don't want it to burn. And then we try to inject into an engine, and I want it to burn nice and clean and not leave deposits. But that's not what they're designed to do. So putting motor oil and trying to extend it is a rather foolish thing to do.
Old boss had a propane tank about as long as these tables. I don't know anything else. He drained the oil and stuff out of the cranes. Dump them in there. What? What are you talking about? I never did want to do it. I just felt really stupid pouring that oil in that damn tank for some reason. He's had us pour all kinds of stuff in there. I almost think he had us put antifreeze in there one time. I'm not real sure. What's it do? He's asking. Oh, it oxygenates the fuel.
No, it doesn't
I feel real stupid putting it in there. I did it. all the
So I
time.
would say don't experiment with it. It's not a good idea. So unless you go do some chemistry classes and get into it, you need to do a lot of research before you even go into buying waste oil from McDonald's or those types of things and trying to put that in your vehicle. Make sure you do the research and figure out what changes you have to do. So it's not something you just pour in one day and say, hey, that's all cool. Okay, so we're going to stop there.